Welcome to Top Tips. Each session, we will provide you with 5 simple tips to help you with your IT or with your data. If you manage or work in a business between 1 and 50 employees, then these tips are specifically for you. Each tip is non-technical and jargon-free. You need no technical experience to use the tip. Each one is intended to be simple and effective. My promise to you, 5 bite-sized tips in no more than 15 minutes. We'll give you the tip and we'll tell you why it will help you. It's all positive. It's not intended to intimidate or scare. If you have any questions, please add to the comments at the bottom and we'll get back to you. Today's session digs into what we actually mean by data and what actually is data. This is a really basic session where I am just going to talk about what we mean by data and what it actually is. This is intended specifically for people who know very little about it, and I've tried to simplify this right back to the basics. For many, this is very straightforward information, and sometimes it's easy to forget that it's not obvious to many people who can find the subject of data very intimidating. So if you feel you already know the basic facts about what is data, then don't be too embarrassed to move on. So, following a request by one of my followers, here is a set of top tips just on the basics of data. If you felt data to be very intimidating, then these tips are especially for you. So 5 simple, non-technical tips in less than 15 minutes designed to guide you around the topic of what is data. Tip number 1. Unsurprisingly, what is data? Data is raw information in the form of facts, figures, and symbols that can be collected, processed, and analysed to gain insight or make decisions. It's really that simple. And in that respect, it's anything. And for the most part, there is so much data around that we're using in our day-to-day lives. But let's just take a quick pause and check in on some of the basic terms. So, data collection. So this is just a simple meaning of receiving data from somewhere and putting it somewhere safe to be used later. This could be as simple as just reading a book and remembering what you've read, through to, say, recording the finishing times of a set of athletes in a race. Data processing. This is where you take the data and you make some changes to it, possibly adding to it, summarizing it, or doing something similar. So for example, if you had recorded the times of the sprinters in the 100 meters Olympic final, you might process this data to, say, add the names, the nationalities of the athletes onto the list of times that you'd already recorded. You might want to record the fastest time, who ran it. You might want to add the fact it was a world record. These are all examples of data processing. And then data analysis is drawing out some useful information from this data that helps informs or makes a decision. So for example, was the fastest time in the 100 meter sprint final a world record? What was the nationality of the winner? Who were the top 3? Is there a trend for the race to be getting faster? These are all interesting pieces of analysis that can come out, which may shape some sort of understanding of the race for you and maybe make you want to do some more information on it at a future point. So for example, if it is a world record, are you going to possibly write a story about it in a different fashion than, say, the fastest race had been 4 years previously? Things like that. They're all examples of sort of making decisions based upon the data analysis that you have done. Now, the bad news here is data processing, although it's one of the terms within there, it actually tends to be used as a catch-all for the whole sort of like end-to-end process there. Okay, and it's certainly used in sort of technical terms, not that we're doing that today. Now, data exists in text, in numbers, in images, also in audio and video. And it's not just in computers. It's in telephone numbers that you store in your notebook. It's business cards. It's opening hours posted on shop windows. It's everywhere. It's certainly ones and zeros in computers, but data has existed since time immemorial. The challenge is always deciding what to do with the information. And the biggest challenge there is that the amount of data created continues to grow as technology gets even more and more sophisticated. Now, it's said that 80% of the data in the world has been created just in the last 2 years. And it's probably true, and it's not going to be slowing down anytime soon. Tip number 2. Where does data come from? Well, back in the Middle Ages, we had monks copying books to preserve the information contained within them. Then we had the printing press and other such things. And all of this was starting to generate data at faster and faster rates. We then got to the point where we had early computers, and individuals had jobs there as data entry operators where they were just typing the information into the computer. Now, those days are long gone. Now we are all generating data, and computers are recording and creating their own data as well. This could be from our social media posts, it could be our fitness trackers, it could be stock monitoring systems, it can be anything. And as I say, computer systems are collecting and they're generating this information as well. Artificial intelligence systems are doing the same. Even this presentation is a new source of data, no doubt will be harvested by all our AI friends out there. And the fact that you're watching it as well will also be getting recorded. I'm always interested in numbers of people who view this, for example. Tip number 3. So what is personal data? Now this gets talked about a lot, personal data, and particularly in the whole data protection and GDPR thing. And most of the focus around data and data protection comes from the use of personal data. And personal data is any information that can be used to identify a living individual. So for example, personal data is not information about the performance of your car. It is not a list of stops that the 12:45 train from Paddington makes. It is not the amount of inventory within your stock systems. But it is personal data where you're recording the fact that Mr. Smith has bought a ticket to go on the 12:45 train from Paddington to Reading, for example. Now, there will be more about personal data and all things data protection in the separate top tips. But as I said, we're all broadcasting information all of the time. And it's important that we understand as best we can what that information is and what it can be used for. Now, again, I'm not suggesting you need to get into the whole technical nitty-gritty of it, but it's always useful to just have an understanding of the type of information that you're using and what it's being used for and what it shouldn't be getting used for. Okay. Tip 4. Quantitative versus qualitative. Now, these are 2 long words that both start with Q. That's never a good start. And I apologize for introducing what seems very technical. But this lives at the heart of what data seems to be. Now, quantitative is data that is numerical, objective, and measurable. It's describing absolutes, and that is what many people think data is. So this might be somebody's age. It could be something to do with the weather, say the wind speed, the direction, the temperature. It's all about the what and the how much. Qualitative data is descriptive, subjective, and non-numerical. It's describing the qualities of something. So that might mean that someone is described as looking young, or it could be by saying it's very windy or it's quite chilly today. And quantitative is what most people will consider data to be traditionally. So it's numbers in rows, it's patterns of things, it's lists, it's all that sort of stuff. But more and more of the data analysis is moving into the qualitative space. And that's the places that the AI is really making strides forward in. So, you know, the use of images, the sort of voice to text, that sort of thing. This is all very much examples of where qualitative data is being used to sort of extract value. And it feels to me that's not going to stop. And if anything, that's going to continue. Tip 5, data quality. This is one of my favorite subjects, and it's really, really simple. And possibly we need to rebrand data quality to give it a better presence in the world. It's as simple as just remembering somebody's name properly. Now, I'm always terrible at remembering names, and I can spend so much time trying to concentrate on remembering that I'm not listening correctly. So social etiquette in these instances is a whole other set of top tips, and one that I'm certainly not qualified to offer. But remember how embarrassing it can be if you call someone by the wrong name or you don't even remember it at all. And this is a great example of data quality. And it's all about remembering it correctly and recording it accurately. And then not in some sort of data version of Chinese whispers, passing it on in error so that further down the line it's being turned into some other name. And it's one of the simplest and most important processes. So remember, data quality, it's very similar to asking somebody their name and then remembering it properly. And I'm Alan, by the way, not Ian, which is happens to me quite regularly that people misremember my name, which is bizarre. I'm Alan Patterson. I work for AIK Advisory. We offer data services and advice. We simplify technology and we operate in a very collaborative fashion. Specific to this, we offer a data security health check, which covers topics like we've been discussing today in far greater detail. We also provide our hierarchy of data needs assessment that ensures that you are using the data in your business in the best possible manner. You can find out more at aikadvisory.com and see some of the nice things that people have said about us there. You can find me at alan.patterson@aikadvisory.com or on LinkedIn. So thank you very much for listening and watching this. I hope to see you soon. That was good.